A really important aspect of electric circuits or electricity is resistance. Resistance is basically uh, the material's resistance is the extent to which it impedes the movement of charge. And so if you look at a lot of this work was done by a guy named Ohm, and the symbol we use for resistance and we call resistance, we measure resistance in ohms, and the symbol we use is this capital omega, right? So that's an omega, omega, capital version, right? So that's an omega. Um, and the symbol we use when we talk about resistance, this is the unit, ohms, and we use R for resistance. So we use V for voltage, we use I for current, we use R for resistance. It gets a little confusing here because V is voltage and we have volts, which are V. I is current and we have amps, which is A. And R is resistance and we have ohms, omega. Okay, so the typical resistance can range from a few ohms, like in light bulbs, in heaters. So something that's intended to get really bright or really hot is going to have a low resistance. Um, but then you get to thousands or more ohms in electronics applications. You get to the human body, and you have significant resistance in the human body. Um, and so that's that part, anywhere from uh, just a few ohms up to a mega ohm. A mega ohm is a million ohms, is something you would encounter in everyday life. And everything has well, there are some things that are pretty close to perfect insulators, but everything has some ability to allow charge to move. And the resistance of different materials is really uh, just depends on the makeup of the material. Diamond, by the way, is an excellent insulator if you want to, go there. Okay, so we've covered the three basic quantities involved in electric circuits: voltage, current, resistance, with the units volts, amps, and ohms. All right, on to the next bit.